using all of our background information now. So now we know how to find the area: squares, parallelograms, triangles, and circles. So we're going to be putting all of that knowledge together to find the area of complex figures. Okay, so I'm going to show you two examples. My time up here is going to be really short, and then you guys are going to work with your table partner to solve some questions on your own, or solve some problems on your own. So this first problem has been in my brain for like the past week, so we're doing it. We're doing it, and I'm really excited about this problem, and you're going to look at it, and you're going to say, Izzy? Hi. You're going to look at this, and you're going to say, are you crazy? And I'm going to say, nope, because you have the skills to solve this, okay? You know, you can just sketch it the best you can. Right. It does kind of look a little bit four-leaf cloverish. So does anybody have any ideas? How can we find the area of this? Shinobu. Yeah, okay, so let me do what you just suggested here. Shinobu's noticing that it seems like there's a square on the inside and then half circles around the edge. So I'm going to draw in that square. Okay, now if there are 4 half circles, how many whole circles is that altogether? 2. So if I find the area of 2 circles and find the area of the square inside and add it all up, we should be able to get the area of the whole figure, right? So let's do it. Oops, I'm already making mistakes. Okay, so my circle has a radius of 2. Okay, so I'm going to do 3.14 for pi times 2 times 2. Okay, so the approximate area of one circle is 12 56/100 inches squared. And we're going to keep a running, kind of like a running total here. So we have circle 1 is 12.56 inches squared. Circle 2 is the same. And then we need to find the area of the square. Okay. The square has this radius right here is 2. So what's the whole distance across? 4. And it's a square, so it's 4 by 4. So what's the area of that square? 16. Okay, add them up. I heard it. So the total area is 41 12/100 inches squared. Okay? So even though that thing looks pretty crazy, you guys have the skills to solve that. Okay? Let me do one more example and then I'm going to cut you loose. Okay, so we have a circle inscribed in a triangle. And what we're going to do is we're going to find the area of the shaded region. So let me put some measurements on there, and then we'll do this.
Adam knows this stuff.
Don't start talking about food. I'm really hungry right now.
What about burrito man?
You've had me at taco. Okay, so what's happening here is we have a triangle. This triangle is 15 meters. The base is 15 meters. The radius is 5 meters. And the height of my triangle, of course this is not drawn to scale, is also 15 meters. Okay? So what we're going to do is we're going to find the area of the triangle. And then if you think about it, this area is missing. So we're going to find the area of that circle and take it away from the area of the triangle to get that shaded area. Okay, so the first thing I'm going to do is find the area of my triangle. So that's a half times the base times the height. So that'll be 15 times 15 divided by 2. So I'm getting 112.5 meters squared for the triangle. And then for the circle, it's pi r squared. The radius is 5. Okay, so 3.14 times 5 times 5. Okay, so I'm getting the area is approximately 78.5 meters squared. Okay. So now what I'm going to do is take the area of my triangle and subtract out the area of my circle. So I'm going to do 112.5 minus 78.2. Okay. And I get that the shaded area, or the shaded area here, is approximately 34 meters squared. Does that make sense to everybody? Okay, so I'm going to let you guys have the rest of the time to work on your slides. I did put the solutions to every single problem in the slide deck as well. So you'll see nine problems, and then after that, the next 9 slides will be the 9 solutions. So check your answer every time you finish one to make sure you're on the right track. Yeah, you can do it with your partner.